Hey everybody, welcome to Goodable Live. We are joining you live from our studio in downtown Toronto. This is a historic space. It's actually a center of creativity. It's a place where Jim Henson formerly had his own workshop. And if you know Jim Henson, you know he created the Muppets and the Fraggles and a lot of the characters on Sesame Street. Well, Goodable is coming at you live from that location, and we are super excited today. Today is a big day in the history of space exploration, space discovery, physics, astrology, cosmology, for some people, religion, you name it, because there were some incredible images that came out today from the James Webb Space Telescope. And joining us is probably the most authoritative person in Canada who can discuss those things with us. Super happy to have you, Erick Dupuis. I want to read your official title so that we don't get it wrong. And then I'm going to tell you sort of in summary what that actually means. Your official title is you are the Director of Space Exploration Development at the Canadian Space Agency. We were joking earlier, Erick, where there was another title that you were hoping that we could give you one day. But in short, you are the Director of Exploration at the Canadian Space Agency, which is really exciting.
That is correct. What our directorate is in charge of is anything that has to do with space astronomy or exploration of the planets in the solar system. So that is a pretty cool job indeed.
You have my dream job. I'm going to be honest with you. Listen, I went into journalism, but I studied as much as I could any kind of beginner level astrophysics because I'm just fascinated with how the universe came into being. And today was a really momentous day because for the first time, after months and months of suspense and being deployed and testing, we got to see the first set of full resolution deep space images captured by the James Webb Space Telescope. Let me ask you the most obvious question in the world. Why are these images so important?
They're mind-blowing. I'll start with that. They just blow my mind away, these images. The one thing, I'm going to compare Hubble and James Webb.
Sure.
Hubble has been just amazing. It gave us the most amazing images of the universe. And now that I see the James Webb images, the Hubble images look blurry. It looks like it's myopic. The images that we saw today are looking further in the solar system. Everything, we're seeing fainter objects. We're seeing objects that are further back in time and at a resolution that is just amazing. So the big difference between Hubble and the James Webb Space Telescope is probably the wavelengths in which it's looking. You probably heard that it's working in the near infrared and infrared. What that means is that it's seeing light that your eyes can't see. So your eyes can see visible light. So basically the colors of the rainbow. And infrared is wavelengths beyond red, longer. And why is that important? Because we're looking at the edges of the universe, right? And we're looking at the objects that are the furthest away from us. And the reason why we could not see those before was because we were not looking at the right wavelengths. So imagine that you're sitting by a train track and the train's coming at you, right? You hear the whistle blowing and the sound changes as the train goes by. It goes from a high pitch to a low pitch.
It's the Doppler effect.
That is the Doppler effect, exactly. And that's because the sound, the waves are being stretched. Well, the very same thing happens with light. And the objects that are furthest away from us in the universe are also the ones that are moving away from us fastest. So basically, the light coming back from these objects is being stretched. And if you're not looking in the right wavelengths, basically you don't see them. They're invisible. Now that we go in the infrared, we're able to see those longer wavelengths. And what we're seeing now, the image that was released yesterday, for example, is at the very fringes of the universe. We're looking at images where the light left these galaxies more than 13 billion years ago. So you're seeing galaxies, how they were forming 13 billion years ago. And that's when the light reaches us. And that light is in the infrared. And that's why we're seeing them today with the James Webb Space Telescope.
And for context for our viewers out there, what's the current estimate for how old the universe is?
13.8-ish billion years.
Wow.
So what we're seeing is basically just a few 100 million years after the Big Bang. So this is basically the very birth of the universe, or I shouldn't say the birth, but the infancy of the universe.
And so let's break this down into very simple metrics so that our viewers can understand. Hubble had been around for I believe at least 20 years, something like
Oh,
that.
more than that.
More than that, produced some incredible images of galaxies and nebula, and we were seeing stardust for the first time and certain cosmological activity that we hadn't seen before. Let's say Hubble was a 5 out of 10. What would James Webb be compared to that?
20 out of 10. If you look at those images, the images that were shown today, we're seeing some images of nebula, for example, nebulae, where you see stars being born. And when you look at this cloud of gas, now we can see, because of the longer wavelength, we can actually get an impression of depth, but also the detail. You look at the detail in those clouds of gas, and it's like lace, right? In the past, all we had was this blurry cloud. It's like you're looking at a cloud, but now we're looking and we're seeing all those fine details, those lines in the clouds themselves, where matter is more dense.
What was your reaction when you saw some of these images for the first time?
I was just flabbergasted, honestly. We saw those images today, and they are so beautiful. Well, they're beautiful, right? I mean, I'll just start there. From a layperson's perspective, I find them just aesthetically beautiful. Now, what's more important is the significance of what we'll be able to uncover with that. The images that look at the formation of the universe, we're working back in time to understand how the universe was born after the Big Bang. Another key instrument on board is actually one of the two Canadian contributions, which is the near infrared imager and slitless spectrograph. So what that thing is doing, basically, it's an instrument. It's able to take images, but most importantly, it's also able to take spectra. So imagine that you're looking at a source of light and you pass it through a prism. You get like the colors of the rainbow. We're using that principle looking at planets that are orbiting other stars. So what you do is, when the planet passes in front of the star, you take a signature and you look at this rainbow of colors, and the gases in the planet's atmosphere will have absorbed some wavelengths, for the same reason that our sky is blue. So that planet will absorb some wavelengths, and those wavelengths are actually very characteristic. You're able to tell which chemicals are in the atmosphere when you look at that. So for the first time now, we'll be able to look at those exoplanets, analyze their atmosphere, and figure out if there are interesting gases out there. And what's really interesting for us is planets that would be deemed habitable, where life as we know it would have a possibility to thrive, or planets where some of those gases could be markers of biosignatures. Basically, you look at the gases and you say, well, in those ratios of concentration or in this abundance, something has to be happening on this planet to generate so much oxygen, for example. On Earth, the reason why we have so much oxygen is because we have plants. Without plants, we wouldn't have all this oxygen to breathe. So we'll be looking, thanks to that Canadian instrument, we'll be looking at those planets, those exoplanets, and basically figuring out whether there's a chance that there's some forms of life, maybe just microbial, but some forms of life elsewhere in the universe. And to me, that is just awe-inspiring.
So this is fascinating for a couple of reasons. Number one is that it's going to give us a very clear window into the potential of life in other parts of the galaxy. It reminds me of Star Wars long ago in a galaxy far, far away. This is literally what we're looking at. But if we do find those, for example, like habitable planets, and assuming they still exist, which they may not, but it's interesting that it would be a Canadian side of the James Webb, or a Canadian contribution to the James Webb Space Telescope, that is opening up that window to help us sort of see the world in a different way. Let me ask you to take what you were talking about and make it a little bit broader, and let's look focus at the bigger picture. And this is what I love about astronomy or astrophysics, because it goes beyond just science. It goes into the very core of like, well, what's this whole universe thing and why are we here? How will the images that are being returned by the James Webb Space Telescope change the way that we understand our existence?
Excellent question. And I like your observation, right? Because this is, I call it civilization scale science,
Hmm.
because it's not just science that a scientist does in his basement or in her basement. If we understand the formation of the universe better, if we discover signs of life elsewhere in the galaxy and other solar systems, those discoveries are not just scientific, right? They're philosophical, they're religious. I mean, it just kicks the basement of everything that we've always known or assumed about our own existence. You know, when I look at those images and I see how big the universe is, I mean, the first image that was revealed yesterday covers about 1/10 millionth of the sky. So one part in 10 millions. So it was like holding, basically the field of view is like holding a grain of sand at the tip of your arm and looking at the size of this grain of sand. And in that image, we saw hundreds, if not thousands of galaxies, each with billions of stars. So multiply those thousands of galaxies by billions of stars by 10 million, which is the size of the field of view. And now imagine how many stars there are in the universe and how many planets are orbiting these stars.
You know, it's so interesting because maybe one of the greatest contributions that the Space Telescope is going to make is to show us that, you know what, we thought the universe was a vast empty space, but it's far, far more crowded, for lack of a better word, than anybody thought it was.
Actually, I have an anecdote actually to respond to that. Another important element on the space telescope, on the James Webb Space Telescope, is the Canadian guiding system. That is the system that's pointing the telescope, and without which no measurement can be made. So if the guider is not there to precisely point the telescope, nobody can take an image. And the precision that we have with this thing is 1/millionth of a degree. So to give you an idea, this is the thickness of a baby's hair seen from a kilometer away. Or if you're in Toronto right now, I'm in Montreal. With that precision, I could notice that you're blinking in Toronto, just looking at you. Well, notwithstanding the curvature of the Earth, but from that distance, just seeing you blink in Toronto from Montreal. So that system that is fundamental to all measurements, that's also built in Canada. We did a calibration run just a few weeks ago, and they decided to point it at a dark portion of the sky. They said, well, let's pick a black spot because we want to see if we have pixels that'll come up to show that, well, they're defective because they're seeing light where there's no light. So they just stared at this part of the empty sky. And when they got the images, it was just full of galaxies everywhere. Wow. Full of galaxies that we had never seen, that we did not know were there, because it's a part of the sky that's usually we think of just black sky. And the image was just galaxies everywhere, pockmarking the image. It was just insane.
I can't imagine being in a room full of scientists and researchers as those images are coming in for something that you think is empty, to see that it's full of elements and potential life. That must have just been a life-changing experience.
Full of billions of stars.
So here's how things typically work. You know, NASA will make an announcement. It hits the news cycle. We look at the images, our jaw drops, and then a few weeks later, you know, something else happens and the media attention goes off to that. Walk me through what would be a big sort of aha moment or a eureka moment over the next several months where the telescope would return something that would completely change the foundations of what we think the universe is. What could that moment be?
Well, I'm not an astronomer by trade, but the one thing that I'm really looking forward to is when we look with the nearest instrument, the Canadian instrument that is analyzing the spectra that can tell the chemical composition of an atmosphere around a planet. What we saw today was a hot Jupiter. So basically, that's a planet, that's a big planet the size of Jupiter that is orbiting very close to its sun. So it's impossible to have life there. Like, it's really hot. It's like an inferno. However, once we start looking at those rocky planets that are in the habitable zone to their sun, just close enough to for the water to be liquid and not solid, just far enough for the water to be liquid and not gaseous, but to have liquid water on the surface. Once we start looking at those rocky planets that could have atmospheres just like ours, I think this is when this will truly capture the public's imagination if we discover something interesting. Obviously, all those beautiful, aesthetically pleasing images of nebula and galaxies will also be very exciting. So I'm looking forward to see these things coming down and hitting, basically being available for everybody.
Let me ask you one more big question before we go. And it has to do with life on Earth versus what we're doing in terms of exploring the universe around us. There are a ton of problems here on this planet. There's climate change, pollution, poverty, unemployment, just you name it. What is it about the exploration of space that brings out that sense of hope in humanity, or that sense of, I don't know if unity is the right word, but there's something about the exploration of space that for some people instinctively is just important. And it speaks to the core of who we are. What is it about space that people should be excited about, and people should begin to see the value of?
Well, let me see. What gets me out of bed every day is thinking that I'm working on something bigger than myself. Right? I mean, you can work on many things, and believe me, we all should. We should work on very worthy causes, and we should all do volunteer work also outside of work to help all these causes go forward. In the case of the exploration of space, it's working on something that's just grand, right? I mean, the universe there's nothing bigger than the universe that we know of, right? So understanding that, advancing science, and when I think of advancing science, there's two sides to that. There's generating the new knowledge so that mankind can benefit from it in the future and understand better what's happening in the universe, but what's happening in the other planets. The other aspect that I love very much is the fact that it's inspiring. It's keeping kids in school. It's making the next generation interested in contributing as well, and in staying in school long enough so that they can help solve all of these problems that you just mentioned. Because if we keep these kids in school today, they'll be able to work on these problems of poverty, environment, pollution, and the exploration of space. And to me, that's what I see as my ultimate job in the end, is making sure that all these kids are wowed and that they stay in school long enough to be able to take the relay after me and work on these projects.
I love how you frame that, take the relay and sort of move it forward, right? And sometimes all it takes is an image that somebody sends you on a phone to say, hey, have you seen this? When you look up at the sky, we don't see it with our eyes, but we now have the tools in place to be able to see it in a profound way that could change careers, it could change lives. Hopefully it'll change this planet for the better. Maybe people will start to see that we really are, I think, as one of I think it was astronaut Drew Feustel might have told us this, or Chris Hadfield earlier, but they said we really are just a blue marble floating in space, and we're vulnerable the same way that a lot of other planets or systems out there are vulnerable. And sometimes
Absolutely.
when you see the vulnerability that we all share living on this planet, because right now it's our only planet, it's all we got, right? Maybe one day we'll have more, but hopefully that'll inspire something else as well. Erick Dupuis, we could talk about this forever, but you've been so gracious with your time. I want to thank you for joining us here on this Goodable Live. Is there anything else you'd like to add for people that are just casually curious about these images that we haven't touched on?
Well, I'll say go and look them up, right? If you're just casually curious, um, go look them up, go get awed by our universe and everything that has to be learned about it. If you're a kid and you're watching us, or if you have kids, stay in school, because you're going to be able to land that dream job after you do all these years of study, and you're going to be able to work on things that are just amazing if you stay in there.
Perfect. Erick, thank you so much for joining us. We're grateful for your time, and to our viewers out there, thank you for joining us. Don't forget to follow us on every social media platform. Find us on Twitter, Instagram, TikTok, and of course, YouTube. Don't forget to hit that subscribe button for those of you that are watching us on YouTube. We are focused here at Goodable on sharing only good news, and that includes science news, it includes technology, it includes good news about climate change, refugees, food, you name it. And we are working very hard to put an end to all the doom scrolling that takes place of people watching the news. So thank you everybody for joining us, and we will catch you on the next Goodable Live.